Ladies and gentlemen, hello and welcome, coming to you not quite live from One Take Studios, where we are solving compound inequalities today. That sounds like a blast. Compound inequalities. I think I've heard the word compound before. Anybody remember from English class talking about something called a compound sentence? Compound sentences in English are actually two sentences, and they're joined together like fun words like or and. So this happens or that happens. One sentence and another sentence. All right, this is the same kind of thing, but for math. Instead of having English sentences, we have inequalities. So compound inequality means that we have two inequalities, and we're going to use these exact same words. All right, specifically or and are the two words that we would use to join inequalities. I'm going to show you some simple examples of this so we can get a feel for it, and then I'm going to show you what it looks like to solve them as well. So, next up here, first example. This would be an example of a compound inequality. I have two inequalities. I have the word or in the middle. So x is less than or equal to -1, or x is greater than or equal to 2. Well, what makes it or? First of all, the word or is in the middle. That is a huge clue. Anytime you have or for a compound inequality, it has to have the word or in it. But think about this as well. Could I say and? Would it make sense if I said and? Think of a number smaller than -1. What's a number smaller than -1? Let's say -5. -5. Is -5 bigger than 2? No. Is there any way to pick a single number that makes both of these true at the same time? No. Let me show you what the graph looks like for this, all right? So think just two graphs on one line. X is less than or equal to -1, or equal to means we're doing a lovely closed circle here, and less than means we are going to the left. So the first inequality is talking about all of these numbers. X is greater than or equal to 2. Again, or equal to, we're going to do a closed circle on 2, and it's greater, so we're talking everything up here. So the graph of an or inequality has part of it going one way and part of it going the other way. There's no way to make both of these true at the same time. Either a number is here or a number is here, but it can't be in both places at once. All right, as opposed to, look at the way this is written. This is a little bit different. You don't see the word and anywhere. I told you that inequalities with or have to use the word or. Inequalities with the word and don't have to have the word and. By placing the variable in the middle between your numbers, you are saying, I have two things, one and another coming true. So if I think about this for a second, let me just cover up this part. That says that 3 is less than x. So let's get a visual on that. 3 is less than x. If I was going to graph that, I would want to have an open circle, because it's just less than, it's not or equal to, an open circle, and the x is on the big side, the 3 is on the small side. So I'm looking for the x's that are bigger. So I'm going to want to shade this direction. I'm going to stop shading for a second. I have a reason. Hold on. This one, if I cover up this part, says that x is less than 5. Well, what if I'm graphing that? Well, okay, less than, not equal to, so we'll do an open circle at 5, and less than means we're going to the left. Oh, look, the shading that I stopped, it sort of picked up. This says that x is between 3 and 5. This says that the x value is between 3 and 5. We can see it in the shading. And it's entirely possible for both of these things to be true. If I pick the number 4, is 4 both greater than 3 and smaller than 5? Yes, yes it is. All right, so this is what and looks like, and this is what an and graph looks like, and this is what or looks like, and this is what an or graph looks like. All right, so let's take this to the next level then. Paying attention then to equation solving and what will happen. So I've started us off again with or. So if you think right off the bat, and I'll wait for my camera to stop fuzzing out a little bit there we go. Right off the bat, by the time we're done solving and graphing this, you should have an idea as to which one of these graphs it's going to look like. Because of the word or, we're talking one direction or the other direction, but not both. These are two different inequalities. They are joined by the word or that makes it compound. Treat them individually for a moment though, would you? Think about solving. If I wanted to solve this first one, I would want to subtract 1, working on getting that x by itself, undoing everything around it, so that's gone. That gives me a 2x here. It's still less than, and 7 minus 1 is 6. And then my x still isn't by itself, so I'm going to undo the times 2 by dividing by 2. That goes bye-bye. And I'm left with, can I squeeze it there? I think I can. No, I'm going to put it here. X is less than 6 divided by 2 is 3. All right, so this is part of my answer for my compound inequality. I've solved part of it. That was so much fun. I'm going to go back and do another one because 2 for the price of 1, ladies and gentlemen. We get to do 2 problems for every problem today. Woohoo! All right, this is x minus 3. Again, I want the x to be by itself, so I'm going to do plus 3 here and a plus 3 here. Dun, 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 dun. That's going to undo it. There's my x by itself. This is still greater than, and 5 plus 3 makes 8. All right, so what we are saying here, according to this, is that one thing or the other is true. Either my x's are less than 3, or my x's are greater than 8. All right, well, let's graph that, shall we? I think I can I'm going to put the graph right here. There we go. All right, so I know I've got to have a 3 and an 8 on it. I'm going to make it a little bit long here. Okay, let's do that. I'm going to call this guy, I think, 8. So 9, 7, 6, 5, 4, that'll be 3, and then 2, 1, and 0. These are both less than, greater than, not equal to. So when I graph them, I'm doing open circle at 3 and an open circle at 8. This one says I'm going less than 3. The x's are smaller, the 3's are bigger. So if the x's are smaller, we're going this way. There's my shading that direction. And this one says that my x's are bigger than, greater than 8. So here's 8, and we're going to go up this direction. So either this or this is true. My number is either here or here. So just like our last OR graph, we have this split graph, so to speak. One goes one way, one goes the other. All right, last one. And we're going to set this up with an AND scenario. Okay, this is a little bit weirder than this one. How do I know this is AND? I do not see the word OR. The word OR has to be there for OR. The word AND does not have to be around for AND. This is AND. It looks kind of like this one, but the middle is a bit more complicated. This one we were able to view as 2 separate inequalities. It is my very strong recommendation that you also view this as 2 separate inequalities. All right, I'm going to cover up this part of it. That says negative 4 is less than or equal to 6 plus x. That is an inequality. I'm going to write that down. I'm going to slide it over a smidge and write negative 4 is less than or equal to 6 plus x. Then I'm going to cover up this other end. This says 6 plus x is less than or equal to 0. I'm going to write that over here. Slide it over a smidge. 6 plus x is less than or equal to 0. Ladies and gentlemen, this is what AND looks like if I take it apart. Notice I didn't split the 6 plus x in half. The 6 plus x went with the negative 4. The 6 plus x also went with the 0. It's doing double duty here. If I split this, now I can go back to my solving. You can try to solve it without splitting, but it's usually a bad idea for most humans until they get really good at this. So if I'm looking at solving right here, again, I want to get the x by itself. That's a positive 6. I want to undo that. Minus 6 here, minus 6 there. All right, so the 6's are gone. Negative 4 minus 6 is negative 10, is less than or equal to, there is my x by itself. I'm going to slide this guy over a smidge, just a smidge. There we go. And then the same thing over here. Trying to get the x by itself, get the 6 go away, minus 6 and minus 6. And so that's gone, boom, there's my x by itself, and we've got less than or equal to negative 6. If this is AND, it should look like this, right? It should be possible for both of these things to be true. If I switch this one around, this is the same thing as saying x is greater than or equal to negative 10. And so while this is a lovely answer right here, some people just have an easier time understanding it flipped this direction. But notice in both cases, the small end of the arrow is pointed towards the negative 10, and the x is on the big side. So both of these things are saying x is bigger than negative 10. X is bigger than negative 10. This one says that x is less than, x is smaller than negative 6. Is it possible to have a number that is both bigger than negative 10 and smaller than negative 6? I hope so. Let's find out, shall we? All right, so let's get this graph going again. I know it's going to have a -6 and a -10 on it. Yeah, I think that's enough space, I think. So we're talking, let's say that guy's -6. That means this guy would be -5. Go in the other direction, -7, -8, negative squishiness, -10, -11, and -12. All right, so there's the numbers on my number line. Ooh, it's or equal to this time, so I want to have closed circles. One closed circle at -10 and one closed circle at -6. Again, this is saying I want numbers to be bigger than -10. Bigger than -10 is this way. And this says numbers that are smaller than -6. Here's -6. Smaller is this way. Hey, I can do that. I can have everything in between these two. All of these numbers are both things at the same time. These numbers are, like -8, for example, is bigger than -10 and smaller than -6. All right, so if you've been working with inequalities, this really isn't a brand new thing. It's just that you have 2 for the price of 1. Hey, they're on sale. All right, so patience, please do actually separate your and statements if you're solving, and keep in mind what your graphs should look like. That way you've got a feeling for it going into the problem. Have fun, practice, enjoy.